Hi everyone, so now we will look at the tutorial questions for our week 2. So our week 2 is about calculating the electric field from a point charge. From a point charge, okay, from a line charge, right, and for the surface charge. Okay, so this is what we have talked about in our lectures. So we'll be trying questions related to this. Okay, first of all, let's look at the question number 2, okay, in your module. Alright, so now you have 5 identical. Identical, it means that, same. 5 identical 15 microcoulomb point charges and are located at the center and also the corners, okay, of a square. Okay, this is a square. And this square is defined by -1 to 1 for its x and also y. Okay, so this one is telling you the dimensions, the dimension of the square. And this square is located at the position z equals to 0. Z equals to 0. So the first question is asking you to calculate the force. Okay, we're not going to proceed these questions. Okay, you can try yourself. It's very similar to the solutions that we have tried last week, okay, in our week 1. So we are going to proceed to question number 2, that is to calculate the electric field intensity at 002. Okay, so this 002 will be our observation point. Observation point means that we want to observe what the electric field intensity at these positions. Okay, so first of all, we draw the charges, okay, they are located at the center and at the corners. Okay, there are 2 options for you, whether you want to draw it on 2D or 3D. Okay, so this is at the right hand side you have the 2D drawing, and you can see the square, right? So this is the square, right? So the dimension of the square, you just follow the dimension that is mentioned by the questions, okay, which is this one. The x is from -1 to 1, y is also from -1 to 1. Then you locate the charges at the corners. Okay, you can label it Q1, Q2, Q3, Q4, and then the last one will be at the center, Q5. This is the last one, Q5. Okay, so this is a 2D illustrations. You can proceed to 3D illustrations, okay, which is on the right hand side. Okay, so there are charges, okay, and you can locate also your observation point 002. Okay, 002 is over here, 002. Okay, so now you want to find the electric field intensity, that is the E. Okay, that is the E. So in this case, we have more than one charge. Okay, so meaning that we have to do the summations of electric field by using the superposition principle. Okay, so in order to get the ET, so meaning that you have to find E1, E2, E3, E4, and E5. Okay, so the general equation to find the E will be this one. Okay, this is the general equations, and the labeling over here, 1 and 2 actually depend on which charges, okay, the electric field from which charge you want to calculate. Okay, so if, for example, I want to calculate the electric field, okay, because of the Q1, due to Q1, then you will label it as E1, Q1, R1 here. Okay, then you insert the values that you know. Okay, for example, the value of the charge, okay, the value of the charge, right? Okay, and then you move on to calculations of the distance vector R1. Okay, R1. So R1 is, you take the observation point. You take the observation point. I cannot erase like this. It's okay. You take the observation point, which is this one. This is the observation point, okay, minus with the position vector of the Q1. Okay, so this is the distance between steps. You just insert it. Okay, so here I have square root, but here I don't have square root because of this square. Okay, so you continue the calculations, right? So you get this value, E1. Next, we move on to E2. Okay, E2 is at the other positions. Okay, E2 is over here. Okay, so you can see the coordinate, it is 1, -1. Okay, and at the position z equals to 0. Okay, so you can use these positions over here to find the distance vectors. And this is again the observation point. I did not write down the front part because they are the same. Because it is the same like the E1. Okay, because this thing is the same. The value of the charge, the 4 pi epsilon naught is the same. And the distance is also the same. Am I right? Okay, you can see the distance of all these 4 charges. Okay, you have 1, okay, 2, and then 3 and 4. Okay, the distance away from this observation point is the same. And the distance. Okay, so that's why I just use the values over here that I calculate in E1 and put it here. Okay, and then you get the other things. Okay, you get the other things. Right, this is the answer of a E2. Okay, and then you continue for the E3. Observation point is over here. This is the locations of the Q3. Same thing. Okay, then you get the answer for the E3. Okay, and then move on to the E4. Okay, so taking the coordinate of Q4. Coordinate of Q4. Okay, observation point. Front part is the same. Then you get the answer over here. Right. Okay. Answer over here. And E5. So E5 is something that is different compared to E1 to E4. Why? Because its position is at the center of the square. So the distance of it towards the observation point, will not be the same like the Q1 until Q4. So you have to calculate yourself for the E5. Okay, so putting the value of Q5. Okay, and here you have observation point, putting the coordinate of a Q5. Okay, then you get the distance. Okay, and then you get the final answer, 33.7, and only in the Z positions. Now we need to sum them up, and if you observe, okay, you can see that their X value and Y value can be cancelled out. For example, this one can be cancelled out with this. Okay, and this, both of them, they are positive. Okay, they can be cancelled out with the term over here, which are negative, and the negative over here could be cancelled out with the positive over here. So in the end, you only left the Z component, and all of them has the same value. Okay, this one cancel out. Okay, so you just multiply 4 over here and add with the value here. Then you get the total electric field, that is 107.6 kilovolt per meter, and in the Z positions. Alright, now let's move on to the next questions. Okay, so you have point charges. Okay, point charges Q1 and Q2, and they are located at these 2 positions. Okay, so if the Q2 value is 4 nanocoulombs, 4 nano, okay, find the value of Q1. Okay, so now you're not going to find the F, or you are not going to find the E, but you are going to find the Q. So meaning that they will give you the informations about the E and also the F. So we have tried these questions, okay, in our week 1. So now we are going to try this thing now. Okay, so now they are telling you that the electric field intensity, which is the E, at these positions, so this is the observation point, okay, observation point, has no Z component. Has no Z component. What does it mean? Okay, so our electric field is a vector quantity, and it has the EX components, right? And it has the EY component as well as the EZ component. So question is telling you that there is no Z component for this E. Okay, so meaning that this one is 0. The EZ is 0. Okay, but they didn't tell you what is the ES, what is the EY. Okay, so this is the information given, right? So maybe you have no idea how to start, but since they give you the information about the electricity, let's form any questions related to the total electric field. Okay, so since here we have two charges, Q1 and Q2, so we are going to have a E1 and E2 to be the E total. Okay, we add them together. Okay, so these are the equations for the E. Okay, I think you are familiar with it. So try to plug in the value that you know. Okay, so E1 you have no idea, so you leave it. Q1 you have no idea, so you leave it. Okay, so for the R1 it will be the, okay, you will be taking the position vectors. This is the position vectors, okay, of the observation point minus the position vector of a Q1. Q1. So position, this one is the observation point. Observation point. This one is the locations, okay, from the location of Q1. Okay, so this is the distance. So over here is square root 82, and over here is 82 because of this square. Same as the Q2. Okay, so for the Q2, you know what is the Q2, right? And you know what is the coordinate of Q2. And then this is the observation point. Okay, so finding the magnitudes. Right. So I think this part you are familiar with. Okay, so you can see I actually combine all these things here. Okay, I combine them to get the value, this one. And same as this part, I combine to get 0.181. Okay, so now let's try to solve. I didn't multiply it, okay, because I know that I won't be using all the X component and Y component, okay, because they are unknown. Okay, I don't have idea about what are their value. Okay, I want to solve for the Q1, so I must form an equations, okay, that has only one variable Q1. If I consider about the EX and also the EY, means that equation will have two variables. I cannot solve it. So I can only use the informations given by the question, that is the EZ equals to 0. So I will only focus on the Z component. Okay, so I take this 9, okay, the 9 multiply with the term over here, okay, and the 5 multiply with the 0.18. Okay, so now you can see I have formed an equations that has only a variable, one variable, that is Q1. Then I can solve for the Q1. Okay, so from the calculation you can get your Q1 equals to negative 8.3 nanocoulombs. Alright, so coming up next is this practice exercise 1.7. Okay, so now you have a circular ring. Okay, circular ring. So what is circular ring? Okay, ring. So we have a circular ring. This is the ring of a radius A. Okay, the radius is A. Carries a uniform line charge density. Okay, line charge density. Okay, and is placed on the xy plane with axis the same as the z axis. Okay, so here is your z, is your y, and is your x. Show that, okay, you have to prove, to prove that the electric field at this coordinate 0, 0h, 0, 0h, I will put it here, 0, 0h. H will be the distance from the origin, okay, to this observation point, h is equals to this one. Okay, so this one is a question related to derivation. You have to derive. Okay, you have to derive from the equations E equals to integrate rho L dL, right? 4 pi epsilon naught, okay, R square R. Okay, so the term over here is equals to Q, right? The derivation, how this equation is going to transform to become here. Okay, so I'm not going to do the derivation here because it is already available in your PowerPoint notes or in your module. Okay, you can refer to the steps how the equations of E is transformed into these equations. Okay, you can refresh it yourself. Okay, we move on to the question number 2. What value of H? H, where is the H? H is over here. So what value of H will give you the maximum value of E? Okay, what value of H will give you the maximum value of E? How to do it? How to do it? Alright, so I will take the equation of the E, okay, from the question number 1. So this is the equations. Okay, so this one is the magnitude, right, the value, and this one represent the directions. And in fact, we can plot a graph, okay, E versus the H, okay, using these equations. Okay, so you might get something like this, for example. Okay, something like this. If you want to know the maximum value of H, the value of H that give the maximum value of E, you have to perform differentiations. Differentiation that you have done before. Okay, so when you are performing the differentiation, you are actually finding the slope. Because differentiation is to find the slope, right? The end, the slope, the gradient. The gradients. Okay, let me give you an example. If I have an equation y equals to 4x, okay, plus 1. So this is a straight line, and y equals to mx plus 1. So the m, which is the slope, is equals to 4. You can get this value by performing the dy dx. Differentiation with respect to the x, you get it equals to the 4. So this 4 is telling you the slope. The slope, okay, of the line. Okay, so when we are performing the differentiations for the equations of E versus the H, we could get the slope of the curve. Okay, when the electric field is maximum, okay, for example, at this point, it's maximum, right? Okay, the slope over here will be equals to 0. The maximum point. Normally, the maximum point, it wouldn't have any slope. So the slope is here. It is equal to 0. So we need to use the equation of del E, del H equals to 0 in order to find the value of H. Okay? Right. So this is the explanations. Right. So now see how I'm doing it. I'm taking only the magnitude. You see there's no vector components already. This one I didn't include it. Okay, I just focus on the magnitude. Okay, so I split it into two parts. One part is constants, okay, so this part is the constant, and this part has the variable h that I want to differentiate. Okay, so now I rearrange it. You see, I haven't differentiated that. I just rearrange it. Rearrange this part. Okay, then I use the product rules. Okay, product rules, you still remember? We have learned it last semester, product rules. So I split this into two parts. One is a U, okay, the other is the V. Okay, so the product rule is you take the U, multiply with the V prime, and then V multiply with the U prime. And this thing and this part remain the same, because it is constant, remain the same. Okay, right, remain the same. So I do the differentiations. Okay, you have to do it slowly. Okay, how to do it? For the V prime, V prime is you take the negative 3/2 multiply here, and this one minus 1, and then over here you differentiate become 2h, and this one is V U prime. Okay, right, then we try to actually simplify. Okay, we simplify it. Okay, we simplify it. Now we want to solve. Okay, so as I tell you earlier, the del E del H will be equals to 0. Okay, this is the point where the E is maximum. Okay, E is maximum. So this one, I'm going to bring it to the left side. Bring it to the left side. So it will become 0. It's like cancel out. Okay. And then this one, I'm going to move it to the left side. So the negative missing become positive. And this one remain. Okay. So in order to simplify this thing, I divide my left side with this term. Oops. Is this term? And I cannot just divide it at the left side. I have to divide it at the right side as well. Okay? So when you cancel it, you left the 3h square. And over here, you can do the calculations. Then you can see this thing. Okay. Right. Eventually will become 1. Okay, then you solve it, and your h is equals to plus minus square root s squared over 2. So this one would be the positions where your h, this one will be the value of h, okay, that will make your electric field to be maximum. Okay, then we move on to the next questions. If it's over here. If the total charge of the ring is Q, find the E as the A shrink to 0. Okay? Shrink to 0. Okay? So this one will be your ring, right? This one will be your ring. When your A shrink to 0 means what? The value of the S shrink to 0. So it means that smaller, right? Okay, smaller, until approximate to 0. So now it's like a point charge. It's like a point charge. And they give you the Q. Okay, they give you the Q. Okay, so the electric field of a point charge is represented by this one. Okay, so you can insert the value, okay, that is given to you in this ring case. Okay, so in this ring case, the observation point is 0, 0h. So you can take the 0, 0h minus the positions at the center here. Okay, so you will get hz and divide with the magnitude and h square over here. Then you get this thing as the electric field. there is another way of doing it, okay, where we approximate the equations, okay, based on the equation of the ring. Okay, so this is the equation of the ring right here. When the A is 0, okay, you can cancel it. And this thing, you can simplify with the term over here, okay, to get this one. Okay, to get this one, simplify. Okay, so you will get 3. It's a bit messy. I think maybe I will write again. And do it again. Okay. So over here, so it's a h square, okay, 3 over 2. Okay, so you will get h power 3. So now your E will become rho L. So no more A. And then h over 2 epsilon naught h power 3. Okay, right, h power 3. This one remain. And then this thing is power 1. Power 1 minus 3. Then you will get rho L h negative 2 or negative 2. Okay, so I can move it at the bottom. Negative 2. So it will be 2 So question tells us that the total charge of the ring is Q. Right. This is a line charge. Okay, so the Q is actually integration of rho L dl. The length of the ring. Okay, so the length of the ring, okay, dl, you can refer to the table. Okay, the dl for the cylindrical coordinate would be r d theta. Okay, and the theta is equals to 2 pi and rho L. So meaning that the Q is equals to rho L r 2 pi. Okay, so now I'm going to replace the rho L with this term 2 pi r. 2 pi r. Okay, so I'm going to replace here Q divided with the 2 pi r. So what you get eventually is Q over 4 pi epsilon naught. So you have the r. Wait. R square. Alright, yeah. Here, so here the R is the radius. The R is the radius. So the R is equals to 0. Is equals to 0. So you have this thing. Okay, so you will get the equation which is the same over here. Okay, right. So this is these questions. This is the solution for these questions. Alright, next we go to the example in the PowerPoint. Okay, so this is example number 5. Okay, where we want to find the total charge. Okay, so the total charge on the circular disc. On the circular disc. Okay, so the circular disc is defined by R less than the A. R less than the A. So this one is the radius of the disc. Okay, so at the position Z equals to 0 and the rho S is given. Okay, so this is a surface charge density and this is a constant. So we will be using these equations. Okay, we'll be using these equations. So since this is ds, we will have a double integrations. And you need to identify what are the coordinate system you want to use. So it is a circular disc, so you will use r dr d theta. Okay, r dr d theta. You can refer to the formula sheet, okay, that I shared with you in the author, okay, for how to find this thing. Okay, very similar to the formula sheet in our multivariable calculus. Okay, and then now you have to perform integrations. Okay, this is a constant, so you can take it out. Okay, so this is the result of the integrations. Okay, the solution is over here. We are using this technique. Okay, you can look at the solution here. So I'll be just taking this thing and then I'll insert here. Okay, right, you're going to try and go to refresh back how to perform the integration using this technique, right? Okay, so I put my interval to be from 0 to a. This is a, 0 to a. Then I will get this thing. I will get this one. Okay, when I perform integrations again for the d theta, I will get the next line. Okay, so the next line actually is correct already. You can leave your answer like this. But if you want your answer to be exactly the same like the answer in the PowerPoint, okay, you can do some modifications, okay, to get the answer this. Right. Next, we go to this example 6. Okay, so this is about finding the Q as well. Okay, finding the Q as well. Okay, so the sphere center at the origin and extend to 2 centimeter. So this one is the R. Is the R. Or in multivariable calculus, we use the rho to represent it. But here, we replace it with R so that you don't confuse with the charge density. Okay, use the R. Okay, so if the volume charge density is given by this one, alright, this is the volume charge density as you can see. The unit, find the total charge. Okay, so for this case, because the given one is the volume charge density, you have to use the dV to find the total Q. Okay, so the dV using spherical coordinate will be this one. Okay, the dV, I choose spherical coordinate because the structure is a sphere. Okay, so I can get this thing. Right, so you can calculate it yourself. Let me check. I think you can use calculator, right? Then you can try out yourself. Okay. Next, I'm going to move on to the questions over here. Okay, right, so this one is about finding the electric field. Okay, you can see this is the electric field intensity, okay, from an infinite, okay, sheet of charge. You see, the surface charge density is given, and this sheet is located at the plane y equals to -2. Okay, so find the electric field at these positions. Okay, so first of all, let us draw this plane. Okay, let us draw this plane. Okay, we draw this plane. Right, so this is the plane is located at the position -2 over here. Oops. Okay, -2 over here. Okay, and all the positive charges are on the surface. Okay, now your observation point is 0 to 1. Okay, x is 0, y is 2, and going up. Okay, so this one is your observation point. Okay, next is we write out our equations. Okay, we write out our equations. okay, which is this one. Rho x divide 2 epsilon naught unit vector n. Okay, so the rho s is given, you can just fill it up and divide 2 epsilon naught and divide 2 epsilon naught. Okay, and now the important part is, okay, you must find the unit vector n. So unit vector n will be a vector that is pointing from the plane, okay, you see, from the plane towards the observation point. Okay, I repeat, unit vector n will be a vector that is pointing from the plane towards the observation point. Okay, so this one is 90 degrees. Okay, you can see that this blue arrow is in the y directions. Okay, so here it will be y. Okay, so you get your answer, this one. You can also solve this thing easily using a 2D drawing. So this is a 2D drawing. In 2D drawing, you don't need to draw all the axes. You just draw 2 axes. Okay, the axis that you must draw is the axis that your plane located at. Okay, so your plane is located at the y-axis. So you can draw the y-axis and you locate your plane. This one is the side view of your plane. You are looking at side view. Okay, because the plane is actually very big, side plane. Okay, so the other axis can be x or can be z. It's up to you. Okay, then we look at the coordinate observation point 0 to 1. 0 to 1. Okay, so if you are putting here as x, okay, meaning that you will be looking at the position x, that is 0, and then position y, that is 2. Okay, over here. Okay, so the unit vector n is from the plane, okay, point towards the observation point 90 degrees, and it is in the y directions. Okay, so if you are drawing using the z-axis, z-axis, let me change the color, z-axis. So the location will be yz, so it will be 2, 1. 1 z, 2 over here, then it will be here. Right, z is equals to 1, y is equals to 2, right? So construct an arrow or vector pointing from the plane to the observation point. Still, you will get your n equals to the y. Okay, so you don't need to do 2, okay? You just either use z or either you use x. But this one, you must fix it to be y, because your plane is located at the positions of y. Okay? Right, let's move on to these questions. Okay, so you have plane x equals to 2, okay, y equals to -3. So this is the position of your plane. So there are carried charges of 10 nanocoulomb per meter square and 15 nanocoulomb per meter square, and they are the surface charge density. Okay, if the line at the position 0 and 2 carry charges of this one, you have to calculate the E at this position due to 3 charge distributions. Okay, so we focus on the plane x equals to 2 and y equals to 3. And for the line, you can try it at home or we can do it together in our class. Right, so plane x equals to 2, meaning that your plane is located at the position x equals to 2. Okay, so here I'm using the 2D drawing. Okay, my x is at the position 2, so the axis that I must use is the x. Okay, so when x equals to 2, meaning that this is the side view of your plane. This is a side view of your plane. Okay, and here I pick y. And you can also pick z, doesn't matter. Okay, so if you pick y, So you will be looking at the 1, 1 coordinate. Okay, 1 and 1. Okay, so 1, 1. 1, 1 will be here. Okay, you can see the point, and you can see the arrow that is pointing down. So the unit vector n is in the negative x directions. Okay, so if I pick this thing to be, for example, to be z, okay, this thing to be z, okay, so I will see this thing as 1, negative 1. Okay, so x is 1, 1 is here, negative 1 is here. So this one will be the point. It's still pointing down. Okay, it's still pointing down. It is okay whether the point is here or here. Doesn't matter, because we use this one just to define the directions. Okay, the arrow. Okay, so this one is also negative x. Okay, so put it inside the equation, the negative x, you get the answer. Next, we move on to the plane of y equals to negative 3. Okay, y equals to negative 3. So I'm putting the y over here. And then I put my plane at the position negative 3. And then I pick one more axis. So I pick the z, y axis. So the z is negative 1 over here. And the y is 1. Right. So I get my observation point. So I construct the arrow, the green arrow, okay, from my plane, okay, heading towards the observation point. So the direction will be y. Okay, direction will be y. So you can put it here. This is the row x. This is the row x. And this is the directions. And you will get this one.